Hi, I'm Cheryl Knott, and I am just finishing up the third edition of a textbook called Online Searching. The first two editions were written by Tara Markey at the University of Michigan, and she retired and asked me if I would take on the third edition. So at that point, you might be asking why online searching. If you do a search for online searching using a search engine, you will find that most of the suggested other searches and most of the results will have to do with searching using web search engines. But there are commercial databases and vendors platforms that have some sophisticated searching techniques that students who are preparing themselves for library and information careers really need to understand. So my proposal was reviewed by 3 anonymous reviewers. They had a few different suggestions. A couple of really important ones for me was this idea that the book needs to be made relevant for public librarians and school librarians. So I added information about readers advisory. And I also added 4 interviews with working professionals in different areas of the industry. And one of those was a school librarian who talked just a little bit about how she uses online searching with her students. And then another comment from a reviewer was that students really needed to and wanted to understand how to do web searching better. So I did a comparison of Google, Bing, and DuckDuckGo, and then also worked from the advanced search forms that Google provides to help students learn shortcuts that they could use in the search box. I kept the 15 chapters in the same order as the second edition, but I did do a lot of cutting, adding, updating, and so on. As I was working on it, 3 trends became very obvious to me, and I'll just conclude with this. Trend 1 was the continuing impact of Google. So this idea that you can recall, you can do simple keyword searching, recall a lot of, or retrieve a lot of information, but then let the ranking system show you the most relevant material first. And that works really well. In a commercial database, there are a lot of options for proximity operators so that you can craft a search statement that will help you eliminate right off the bat irrelevant information. And these are just a few proximity operators that are available from the LexisNexis search system. Second trend I noticed was that you can really do a lot of searching from the results page. So there are filters on the results page that help overcome a simplistic keyword search, you know, the weaknesses of that. But there are also links to related articles, or in the case of Novelist, which is a reader's advisory database, links to read-alikes, whether by title, series, author. So the filters on Academic Search Ultimate can include document type, as well as leading students or users to the SARS terms, subject descriptors they can use. They can limit by publication name, author name, and so on. So a lot can be done even after you already have results sets. And the third trend is the ubiquity of research impact measures. You know, charts, badges, tables, beam plots, all different kinds of ways that database vendors and publishers and the publishers of even individual open access journals, finding ways to indicate research impact And this can include the standard bibliographic, bibliometric approaches like, number of times cited, but new altmetric measures as well, such as, how much discussion on Twitter did your research create. And I tried to make a little bit of a parallel to the Goodreads website, where readers can read reviews and rank reviewers and so on. So trying to help librarians think about the impact that reviewers have, particularly in regards to readers advisory. So thank you. I had fun working on the book, and I had fun talking to you about it today.
Okay, hello everybody. My name is Bozgeyikli. I'm an assistant professor at the School of Ontology. And my research topics are mainly human-computer interaction, and I'm specifically focusing on user experience and usability. I also look at serious game development in VR and mixed reality as well. So today I'm going to talk about one of our latest projects called VCR, which is the Virtual Cognitive Rehabilitation. And it's a high-fidelity virtual reality environment for passively activating memory circuits of individuals with mild traumatic brain injury. And as they try to navigate in novel environments. So the previous work is done for the passive navigation of novel environments, which activates the memory system to rehabilitate spatial memory as being demonstrated in problems. And we are creating it for the humans, and we are working with colleagues from the College of Medicine in Phoenix, high school, and Department of Psychology. And this project is funded by Department of Veterinary Affairs. So you can see this tutorial, and I will talk about different aspects of the application in a minute. So here the user's goal is to explore the environment, and also they should visit some specific locations with increasing difficulty, like 2 locations, 3 locations, etc. And the idea here is that we are trying to create an experience for them to create a mental map in their minds, and that will hopefully help with their traumatic brain injury. There will be in total of 5 virtual environments, which are mall environment, airport, school, town, and city, and all will have 16 levels. Each level will have 3 tasks. These are very large numbers for a VR project, but we are trying to create novel environments, a lot of novel environments for users. And these tasks are individualized with a progress tracking. So if they do well, they will get a difficult task. If they are not doing as good as we hope, they will get an easier or a similar kind of difficulty. And we are adjusting the parameters to change the difficulty. These are the common parameters. So degree of similarity is 1, which refers to the similarity of the duplicate buildings. So if it is 1, That means two buildings are same. If they are 0, they are totally different. We are trying to increase this similarity as the difficulty goes. And we have some environmental elements, stationary and moving, to make it crowded and make it a little more difficult for the users. So we are keeping track of various metrics to evaluate the process, like path taken, closest to the optimal path, if they do any U-turns or stops, how long it took them to take that path, and the percentage of the environment that is covered. And we are also using some gamification techniques like stars, collectibles, and achievement coins to keep them engaged. Also, we are also working with the life experience consultants, which are veterans, and we create various test applications to evaluate them and find the optimal interaction techniques for that specific group. They wanted, for example, several military reference editions, challenge coins, range selection, etc., to feel more connected to the application. So we are looking for different aspects to be able to implement it in the game with the help of data experience consultants. So that's it for me. If you have any questions, please go ahead.
We have time for 1 or 2 questions.
Okay.
Sir.
Yes.
Thank you, that was amazing. I was curious how you chose the types of different environments. For example, maybe veterans who are coming back, reintegrating into society after combat, they are not familiar with a mall, maybe, or not familiar with the public sphere, the public spaces. So I was curious how you chose the different environments.
Currently, we are giving them in an order, so they are supposed to try all of them. But we are, as I said, consulting with these veterans, so they are giving us feedback about what environments they are going to be familiar with. The idea here is to give as much novel environment to them, so these are a lot of different environments that they need to try, hopefully help with their TBI if it is successful.
VA hospitals might be good.
Yeah,
They're hard to find a way around.
Yeah. Thank you.
So hello, I am an assistant professor at the iSchool here. My name is Bratt, and I'm going to be giving an overview of a couple projects which I need students for. So if you're interested or would like to just learn some more, definitely reach out. I'll have my information at the end. So the main focus of this talk is going to be how do we start to do research data management in a way that's institutionalized in care. So it's going to pull on some ethics, is going to pull on long-term sustainability for research data management as well. And, there will be apple pie, and maybe a little this kind of pie. Just keep that in mind. Okay, here we go. Before I begin, I would like to recognize that I am a science studies scholar, so everything takes place in a particular place in space, so I'd like to acknowledge the Tohono O'odham and Yaqui tribe, where the University of Arizona now stands. So what are we going to be going over? Well, as I mentioned, there's going to be some baked goods, so just keep that in mind. Then I'm going to go over 2 projects that I'm currently working on, one that I presented at this awesome conference called the Association for Science and Information Technology, and then I'm going to go into some student opportunities for these projects. Mainly these are going to be focusing on the problem of data curation. And I know some of you out there already know what this is, so I might ask you to give me a little definition, just keep that in mind. And then part of this is going to be looking at the practices behind research data management. And this is to promote not only preservation of data, right, and accessibility, but also ethical data curation, this emerging space in research data management. Now, how many of you have heard of the 4th paradigm of science? Ooh, we got some righties over here, mostly because I mentioned it in my last talk, but also it's a new paradigm of scientific production. The previous paradigms were not as data intensive. Take a look at what you see here. What do you see? We see not only machines, right, lots of data production. We see people interacting in a collaborative manner. Science is changing. This is because it's become more data intensive. It's revolutionizing the way we produce data because of the increasingly collaborative nature. But also, there's a problem here. It's not that easy to preserve that data. We have a lot of data, but we're not very good at managing it. Anyone here have photos that are hard to describe? Case in point. Data is corrupted. Key personnel is leave, which is called brain drain. And as Google VP, the Surf worried, we don't have a systematic way of making sense of that data. And as Heidorn, Dr. Brian Heidorn, who's in the room with us, characterizes as the long tail of orphan data. This is dark data that we can't access. Now, there's another layer to this to complicate it. This is an ethical issue as well. Algorithms are at the center of a lot of decision-making with that data. And as Dr. Satya Noble wrote, algorithms are the intersection of technology and society, but also power. So when we talk about research data management and long-term sustainability, which is the focus of a lot of my work, there is this ethical dimension. Now, the goal here is data sustainability. I focus on research data management and curation, and this crosses a number of different fields as well. But there's one driving question, and that is, how are digital technologies changing the way that people engage in curation to enable sustainability over the long term of this data? So, can anyone think of what is research data management? Any definitions out there? Well, research data management, if you didn't know, is a number of activities. It covers a lot of the life cycle, and this is throughout the curation to the publishing of that data. And curation here is actually something that focuses more on the describing, preservation, and facilitating access. So we'll dive into a little bit of more of this theory if you come and work on this project, but for now, I'm going to give you a little high-level definition here, which is to add value and meaning to data. And it's always defined relative to the community of practice. So, as we all know, science is an apple pie. What does this mean? Well, scholars and practitioners are tending to focus on the end of the research data life cycle. If science is a pie, we only smell the end product. We only see what comes out at the end, the papers, the Nobel Prize, the awards. And in research data management, that looks like repository services, archiving, and preservation. It's beautiful. Let me have a slice. We don't look often at what's inside and how it's made. So, in these projects that I'm going to show you, the literature, the studies have really started to investigate data as a practice, data curation as a practice. And they're engaging the ongoing activities of researchers. And this is critical, not only in libraries, but also as organizations develop more ways of collecting data, they're going to need to institutionalize, create norms and practices for data management and for the ethics of data curation. So in these projects, we're going to be looking at this through, put on your institutional glasses, an institutional lens. And I'll get into that a little bit more. But here, we're specifically looking at new ways of institutionalizing, pulling into organizations, data management, curation, and ethical AI. So, in this area, we are going to be talking a little bit more about what it means to institutionalize data management, data deposit. Here, what I want you to take away specifically is this weird-looking chart. What is this? We're going from a T-shaped researcher to a pie-shaped researcher. This is how studies have characterized this so far. Now, focus on the pie-shaped research. What is different? Well, one of those legs is statistics and computing, and the other one is that deep domain specificity. So in these projects, we're going to look at emerging sites right here in Tucson, but also globally, of data management and curation practices using artificial intelligence. Artificial intelligence in data curation and research data management are an emerging area. We don't have a lot of norms. We don't really know what the best practices are. So we're going to be looking at how scientists and libraries, museums, and archives are using AI and how that's becoming institutionalized. Specifically, we're going to look at different team compositions that include statistics, computing, and domain specialization, like this pie shape. But we're also going to look at things like OpenStack experience, high-performance computing, and these kinds of related areas of AI. So my first project that I would love you to get involved with, if you're really interested in this area, is expertise in data curation. This is looking specifically at some library and museum and archive contexts for using AI. In this project, which I presented at the Association for Information Science and Technology this past November, we're looking at different research sites of curation and use of AI. Now, how many of you have experienced going to a museum or a library and interacting through VR or even AR, augmented reality? Yeah. Wow, yes. So more and more sites are incorporating these. This includes the Library of Congress, who's starting to do a report of how machine learning is used in these institutions, as well as the impact of artificial intelligence in museums. Now, data curation. Curation comes from the root of the word to care. So, as we know, a lot of information systems historically do not reflect marginalized voices, rendering them invisible across physical and digital platforms. This is starting to receive a lot of space, a lot of attention in this space, but we still lack a robust discussion about what that means and how AI is being implemented in these spaces. So, in this project, we're going to ask, how do modern curatorial institutions, like academic libraries, archives, and museums, currently employ artificial intelligence to advance equitable systems? As well, how do organizational structures enable the co-design of equitable AI futures? Keep your eye on that co-design, because that's a big method that we're going to be using in this project. So, in this project, we're going to be using speculative design. This is a type of approach where you give it's a discursive practice, and it enables those participants to imagine what the future might be for their library, for their museum, and this will generate and surface some values in design. So we're uncovering the ways that curators are currently employing AI. Now, a platypus is a great example where you say, this is a combination of different features that you might imagine for a future of AI. We can't see what that is on the horizon, but by using speculative design, we can surface some values that are implicit behind some decisions. So, to wrap up here, the research sites that this will be drawn from are 9 research sites in 3 curation contexts, specifically cultural heritage archives, academic library collections, and, wait for it, research data management repositories. So there are a few of them, including the Learning Games Initiative Research Archive, the Noir Lab here at University of Arizona, and we are going to be conducting some interviews, as well as doing some trace ethnography. Now, this is ongoing, so I'd love some help with those interview data collection, as well as trace ethnography. If you're not familiar with that, this is a great chance to get that methodological experience. Here's my contact information. If you're interested in getting in touch with me, very happy to work with grad students. Just applied for a grant that'll be starting in, if we get it, in September 2023. Okay, thanks very much.
One very quick question.
I had a quick question about, have you looked at the implications of people not understanding these scientific processes? And have you found things, I hope you'll stay for my presentation that's in a few people, because I am looking at that related to disinformation, and I mean, the impacts are really huge for people not really understanding the processes that go into science.
That's a great question, because often science is seen as a black box, just as like computers are seen as magical. And so a lot of scholarship in the area specifically of science and technology studies are starting to say, scientists are human, and part of that is it's a really revolutionary kind of thing to do, is to open up the black box of science. So I think still there's a zeitgeist culturally to think that scientists are our silver bullet or are something that transcends human. We go and we become sort of objective, and because of that, we can bust that myth. So I'm really looking forward to how your research is on that topic. Thank you, Dr. Daly.
Okay, so I'm going to talk about ecological phenophase prediction, and you might not know what phenophase is, but the question is when will ecosystems collapse and society end? I'm doing this. So I'm doing this in conjunction with master students from our program, which has since graduated and is working at MasterCard and coming back for graduate education later, PhD, I hope. And then with a couple of people in the university communications and cyber technology center, which are real biologists. I'm only a fake biologist. Damn. Okay, so Phenophase and who cares? So Phenophase is when do things happen in the biological world in ecology. So when do the leaves come out in the spring, when do flowers bloom, and all of those sorts of things. If the trouble is that because of climate change, there's an opportunity for asynchrony, and that's already happening now, where certain ecological events happen out of phase with other ecological events which lead to disaster. So we should really care. So things like the trees are getting green sooner. The birds are in South America, don't realize that's happening. The bugs are here, they realize it is happening. The bugs start eating the trees. The birds aren't here to counterbalance that. And then they kill the tree. The birds arrive. It's too late. The bugs have done their damage. Many of the bugs are already gone in their next phase of the cycle. The birds die. The forest catches fire. Bad stuff happens, so we should care. So there's a competition called Predicting Greenup in the spring. It's being run around NEON sites, National Ecological Observation Network sites around the country, long-term ecological observation sites. And the objective is, can we work out mathematical methods to predict not only what's going to happen this spring, but what's going to happen 50 springs from now if we combine this with our ecological models. So what can we do? Traditionally, the prediction's been done by looking at weather. So growing degree days, when the last precipitation was, precipitation behavior in the fall when the leaves were originally setting, the buds were setting. So those characteristics can be used to predict what's going to happen the following spring. So we did very well in the competitions this year, but this next year I wanted to cheat. So I'm doing that by using more data. The observation is that we have a bunch of cameras situated in NEON sites and many other sites around the United States and around the world. And can we leverage the imagery that's coming through as an extra data stream to fill in the models so that we can improve our prediction going forward? And the picture that we have there that's the pollen cone of a maple tree. So in the spring, the forest turns red in some places before it turns green. So you can use those characteristics to do predictions of later characteristics. It's because of the synchronization of Phenophase. They're locked in time to each other, so there's a high correlation of a previous phase with a later phase. This is human-collected data, so there's several million records, tens of millions of records, created by humans on when do these cones come out, the little red things on the maple trees early in the spring. So this is conglomerate data from a few years, showing us a peak in the observations from humans going out and observing them. So can we exploit that using image analysis instead? So here we have, we're going to use a series of image masks and image segmentation, and then some calculations of red and green ratios within the landscape to see if we can pull out information from the images. So this is an example of a phenocam. There are 393 of them as of this week, spread around the country, including at all NEON sites. They appear at the top of towers and also at the base of towers. They take pictures every 5 to 30 minutes. So we have millions, many, many millions of these photographs across time that we can analyze. So we want to predict when is green going to happen. But you see in this image, there's already green. There's evergreen trees in there. So it's messing up our image. What we want to do is, this is a January image at the Harvard NEON site, where we want to, among other things, we want to take out the evergreens. So what we do is look in January, find out where there's green, make a mask, recognizing where all the green is, and then we can subtract that mask from later images to recognize where This is the June image. Here we have the deciduous trees with leaves and the evergreens mixed together. We want to subtract those out. And then we could put on a mask identifying just, in this case, the general green mask, everything that's green. But this is the green mask versus just deciduous trees by taking out the evergreen. So now we can focus on analyzing just those pixels that will have leaves in the future to do our math. And here we jump ahead to pass a bunch of math and do a graph. So what this is showing us is across a year, starting in January, I forget which year, this is a 5-point median, just to smooth out some of the curves. But what we see is around March, there's an increase in red before the green comes. So we can use that increasing slope as a prediction of when the green is going to occur. So it looks as if we are picking up some of these previous signals. We haven't fit that into our models yet, but there is a Python package for Phenophase prediction that already exists. This is just a list of the models that are already executed. So our next phase is to feed our new data stream into the existing models and see if the addition of that red data and some other colors that appear in there will help to improve our prediction over into the future by doing these analyses. And then we'll be able to harvest, if it works, we can go back to the past and generate things. And also, if we spring in the future, we can release our algorithms and predict what's going to happen, if anything will go wrong. So we need help with modeling and computation and image analysis and things like that. That project is in, the funding for that project is ending. We're putting in for new funding. Related to that, I showed you a curve of humans, collection of information about observations of natural events in the environment. That's done with the National Phenology Network, which happens to be based here in town. Tens of millions of records from tens of thousands of people have been collected so far. But their user interface, the mobile interface, is a little bit of age. And what we want to do is gamify it and add in some augmented reality to make it easy for people walking around in the natural landscape to find examples of the trees and things like that we care about and generate some data for us. Tell us if there's buds, tell us if the leaves are out, tell us if the leaves are falling off, tell us all of those characteristics. Get points for finding the plants that we don't have data for filling in the gaps, those sorts of things. So we need help with game development for these mobile apps, preferably with augmented reality, so that people can find their way around natural landscapes and find the plants that were recorded in prior years and collect new data associated with that. So that's all I have for today. And then we'll take Yes?
How long do the masks last? Do you have to update them over time if there's new growth or there's changes in forests? And do you have
Every year we have to redo the masks. So there's an algorithm that I didn't talk about. There's color cluster analysis that we do on a scene. We do that in January. We also find snow, so we know what the ground is high or we can put that in there. So algorithms figure that out every spring, find an example and create a new mask. And it's different for each location, of course, because the trees are in different places. Yes. Great, thank you.
Okay, hi, my name is Adarsh. I'm an assistant research professor at the high school, and I'm going to talk to you today about something called artificial social intelligence. So you guys have heard about AI, I'm sure the media is blasting you 24/7 about ChatGPT and all the crazy cool stuff that's happening in that area. However, one of the things that AI still struggles with is really understanding the humans that the AI agents work with. So really what AI is lacking is something that we all possess in spades. Well, there's a spectrum, but still, to some extent, we all have something called social intelligence. So what this is the ability to infer what other people are thinking and feeling based on observing them. So really, humans have what's called a theory of mind. So you can, by watching what people are saying and doing, you can kind of know what's in their heads. And so we would like to imbue AI agents with that capability so that they can be more effective teammates. So if you imagine a sports team, if you have a teammate who knows where you're going to pass the ball, they can go there without you having to tell them. Each second of time that you gain by these kinds of tactics can help you win a game. So not only do we want AI to be able to know what's in the head of individual humans, we also want them to have a machine theory of teams. So how do humans interact with each other? What are the team dynamics? Is person A really bossy? Should we tell them to tone it down for the good of the team? These kinds of things. So far, I've been talking pretty abstractly, and our goal, concretely, is to create a suite of modular open source AI technologies for artificial social intelligence. So the way we're testing these technologies is by putting teams of humans working with an AI agent in a virtual test bed. And this might be familiar to you, to some of you. This is a test bed that's based on Minecraft. What we're having them do is simulated search and rescue missions. And since the video can say a lot, I'll show you what one of these missions looks like. Okay, so this is a top-down view of the mission. So
This is Red, I'm a searcher. I'm gonna go right. When you first get in the building,
in the top row you'll see a bunch of...
there's 2 piles of rubble in this first room on the right. At least one of them needs to be cleared, from what I can tell. This big pile of rubble here, 2 of them need to be cleared. 2 big piles of rubble need to be cleared. There's that.
Okay, so that gives you a little sneak peek into what's happening. So the top 3 boxes over here are showing what the individual players are seeing. And there's these people who have to rescue victims that are trapped in a building collapse in Minecraft. And the goal of the mission is to save as many victims as possible. So we are developing agents. Our project is called Tomcat. It's also the name of our agent, which stands for Theory of Mind-Based Cognitive Architecture for Teams. There's sort of 3 main areas that we're focusing on. One is a multimodal dialogue system. We also have a research effort on grounded probabilistic modeling of teams, and also a research line on plan recognition and interventions. I'll talk a little bit about the first 2 and some recent developments. So, humans have both explicit and implicit ways of communicating with each other. So, people might tell you things in words, but their body language, their facial expressions, their tone of voice also conveys a wealth of information. And we want AI agents and AI teammates to be able to pick up on this as well. If you yell at Siri, or if you tell Siri things nicely, Siri can't really tell the difference. We would like to change that. We'd like to have a bit more social intelligence in dialogue systems. One of the recent papers we published was on a real-time rule-based event extraction. So in real time, we're able to extract sort of information from the natural language dialogue between the players in this mission. Things like knowledge sharing, or if people are saying, okay, I'm going to go to this area, we're able to extract that in a machine-readable form and give that to downstream AI components. Another exciting thing, we just submitted this paper last week. We've collected a data set of 10,000 utterances from over 70 speakers, and they're annotated for a number of things. So we've annotated them for emotion, sentiment, manually corrected transcriptions, as well as dialogue acts and adjacency pairs. So our hypothesis is that using all these different kinds of information together is going to be more powerful for predicting human behavior than using just a subset of these. And this data set, I think, is going to be pretty useful for the community, there really isn't anything else like it out there with this level, this number of annotations for utterances. That was dialogue system. We are also collecting data from lots of physiological sensors like brain scanning, FNIRS, EEG, and we're trying to see how coordination as expressed in sort of surface level modalities is reflected in more underlying modalities. Like if people are coordinated in like a game or in their speech, are their brains also in sync? And so far we've collected over 20 terabytes of rich multimodal data, which hopefully we can, I think probably this semester we're going to release it. And there's all kinds of correlations that, exciting analyses that we're planning. So, if you're interested, do get in touch. We also were able to create a model that was able to detect misaligned beliefs between teammates. So we would feed one teammate false information, and our model could actually detect that, okay, that teammate is the one that had the false information. Better than human observers. We have people watching these videos, and the model is able to do better. So what's next? We're really excited to collaborate with the Arizona Simulation Technology Education Center. We want to get this technology out of Minecraft and more into the real world. So we're going to try to do some experiments where we embed this technology in medical simulation training scenarios. There's a whole new set of challenges that come when you go into the real world, but I think we're excited to tackle those. Okay. Any questions?
So I'm curious, are these artificial agents getting access only to the auditory information, or do they also get the faces?
So in the so there's two sort of studies of interest. One was a remote study where we recorded audio communications, but not facial facial video. But the agent has information from other sources as well. Like within the game, the agent knows where the player is, what direction the player is looking, what the surroundings are, etc. So there's that information as well. We're also collecting data, the FNIRS, EEG, those experiments in-house at the U of A. And over there, we're collecting facial video as well. And the agent is going to have information, that information in real time. So,
Okay, hi everyone. I'm Dr. Daly, and I'm going to talk to you about two projects that I'm working with, which are the iVoices Media Lab project and the Immersive Truth project against disinformation. So, iVoices, we are now in the third of 3 years of iVoices, so we're in the research phase. We did a lot with teaching. We started a student media lab in a big gen ed called Social Media and Ourselves, and we also created a podcast and an open textbook. And now we're starting to look at impacts and analyze the stories that came from that. I've got one student, Gabby, here. I'm grateful to have her help with this project. I'm also working with some other doctoral and graduate and undergraduate students. And we are, let's see, what are we doing in the iVoices research project? We're preparing a survey right now. We're almost ready to send it out with everyone who was a participant in iVoices, which should be, I don't know, maybe 500 people. And we will find out through interviews also and focus group data, etc., just what some of the impacts have been on them. And this is a meme that one of the students created. It's been a great pleasure to help students produce media and to use these media as a form of data. It's a little edgy because I come from this world of library and information science where it's, things like open licensing and open culture are something we take really seriously, and we look at really robust systems of getting permission and making sure people understand what they are doing, which is actually pretty different than what social media does, in terms of how students are posting things online today. So it's a really nice training for them to understand what a robust system looks like, because users influence social media systems, and if we help teach students what does it mean to actually really give permission to have your things shared, and to understand the implications of that, then those students, those young people will move forward, and possibly have culture change related to social media use. On the other hand, there's also all these negotiations that have to happen with the IRB that have nothing to do with credit for authorship, for example, and have nothing to do with, or just, have not had conversations, I should say, with things like credit for authorship, and whether students maybe want their things to be, want to have voices in the courses that we are teaching about technologies. So it's been really fascinating work, and I look forward to sharing more results with you as we go on. We've had some really good results in terms of how young people and students have enjoyed the program, and we are getting more of that. So I'm also working on the Immersive Truth project. The mission is using groups and stories to construct and deconstruct graphic and oral propaganda. In particular, right now we're analyzing a set of viral memes. We have 10 in this first set that we're looking at. We're looking particularly at TikTok and Spotify. These are really underanalyzed platforms related to misinformation and disinformation. And we are producing pre-bunking media. And so pre-bunking, if you don't know, it takes a step away from debunking, where you say, oh, okay, this is the disinformative video that you saw, and now we're going to tell you everything that's not true about that. But of course that means we're going to be chasing the lies for the rest of our lives, and we just don't have the time and the capacity to do that. So pre-bunking is something that researchers have really found using something related to inoculation theory. It's this idea that you can prepare people for disinformative media that they are about to see, and you can do that by looking at the strategies of that media. And so what we're doing with Immersive Truth is we're actually using qualitative research, and this includes student understandings of media, which can be super keen. We are using these kind of research methods to understand what is going into some of these viral memes that people are seeing, and to then figure out, can we use some of those strategies to make media that calls into question some of those underlying immersive strategies and dynamics that are in the disinformative media. In other words, can we make truth immersive? So, truth is not nearly as exciting or memorable as disinformation. I'm about to show you a video that's disinformative. I would just like to remind you that this is not true, a lot of what we're going to see, and also you're welcome to call bullshit, like actually with the word bullshit, or just make sure everybody understands, laugh, do whatever, because it's really important to be an engaged audience anytime you're interacting with media, but particularly when you know it's about to disinform you. So I'll show you this video.
Now, I was the founder of the Weather Channel, not the co-founder.
And I'm glad you did, because I am addicted to the Weather Channel. I watch a lot of cable news.
Now, hold on just a minute, I'm not done. And CNN has taken a very strong position on global warming that it is a consensus. Well, there is no consensus in science. Science isn't a vote. Science is about facts. And if you get down to the hard, cold facts, there's no question about it. Climate change is not happening.
Okay, did you hear it? Kind of? Okay. So that is either the founder or the co-founder of the Weather Channel. That's actually a little bit of a topic of debate. There are a few tactics that were included in there that include manipulation of time. This was posted in 2021, but it was actually from 2017. He is now deceased. By sort of rolling back, by using outdated content with climate change, you're rolling back the science, and you're just using someone that people kind of admired, and sort of using his words as though he were saying them 4 years later, which maybe he would have still been saying them. I'm not sure, but he passed away. There are appeals to authority in that video where he talks a lot about how he should be believed and trusted because of his role as founder of the Weather Channel. His science there are some dubious connections to him, being labeled an expert in this regard. And there are ad hominem attacks here in this video. The way he kind of strikes down the CNN interviewer is something that people feel entertained by and also kind of feel behind him about. But really what's going on there in terms of a deeper strategy is this immersive strategy of feminization of scientific consensus in favor of this idea of the cold hard truth, or what I call truth as sport. So this idea that consensus is weak, and consensus is not something that could ever lead to truth, and this is a particularly kind of masculine audience-directed type of strategy, this idea that that the man who bests his opponent, as you saw in this interview, and if you saw the interview as kind of a sports match, the man who bests his opponent is the one who should be believed. And so this kind of thing is actually at play in a lot of media that I see, and so a few different viral memes that we're looking at, including a podcast episode with Joe Rogan having conversations with Dr. Robert Malone, very anti-vax, and it comes down a lot to these ideas of these, masculine arenas where a lot of populism is really focused on feeling disempowered by science and the desire to feel empowered through these more traditional structures of empowerment, such as sport or kind of toughness. So that's just one example of some of the analysis that's going on. To my colleagues who are more experienced researchers than I am, I've been basically an instructor, I think, as you know, for the last few years, and it's been great to be able to do research really for the first time as part of my work in this year. But it's also driving me a little crazy because I somehow ended up with 2 projects. And the way I try to, keep my mind, sane is to keep remembering how they converge and come together. And so the convergence of these projects for me has to do with, student stories proactively shape a data corpus, and student knowledge proactively shapes a data corpus. Qualitative inquiry around technology uses is part of both of them. And we construct knowledge to be shared and taught. Teaching is a really key part of any research that I do and that my teams do. Also, both projects are culminating in open educational resources and open textbooks, that is, textbooks that involve, writing by not just myself, but students that I work with or teach. And then sort of more fundamentally, I think what I really need to do in the work that I do is question paradigms of expertise. If I'm walking into a classroom and I'm nervous that the students might know more than I do, then I don't know why I'm pretending otherwise instead of just asking them what they know. Honoring funds of knowledge is also a real important fundamental theory related to that. Louis Small and Norma Gonzalez in our own education department here have been, they're where the funds of knowledge theory come from, and I think that's a really important theory to understand pedagogically, to understand this kind of work. So I think that's it. Thank you, and I invite your questions. Adarsh?
So this climate change video, how would you go about pre-bunking such a thing?
Question. I mean, we definitely have some of that created already, or actually we're still in process with that one in particular, and that will involve some of this textbook, this immersive truth textbook. There will be a page dedicated to that particular meme. There's a glossary of tactics that we're building where we will be able to kind of integrate, why it is, what are some of these tactics, and you're of course being able to see them in there, but also read about them, in terms of, what you would see in the future. I'm developing a gen ed course that's going to be using this textbook, by the way. So in terms of dissemination, that's one way. But another thing we're doing, which I'm pretty excited about, I don't know if we have the media team resources right now to create video, but we can definitely create audio. And I have sort of forming in my mind right now a very short ad that we could distribute on something like iHeartRadio, where it actually would have the potential to be played on for example, certain, localities for the Joe Rogan podcast or something like that. Some of these, obviously we don't have the money to really just full on put it out there the way Google does with what they've done with some pre-bunking lately, but we can do a little here and there and we can test it. And so I could imagine what I'm thinking about is somebody with kind of one of those grovelly voices, like a man making a commercial kind of voice. I have a friend, I do a little bit of improv performance, and I have an improv performer friend who I've already tapped to kind of do this commercial, talking about kind of truth and science and how maybe you actually, don't want to trust the person who's the worst teammate on the team. Like sort of using some of these same fundamental ideas of sportsmanship, for example, and maybe getting some of the other kinds of toughness, aggression in there as well. We might be able to make TikToks that are very user-focused. We're still trying to figure out what we can do with the team that we have, because it's difficult to get students who produce good media, enough money to produce and enough time to produce what you want to do. So those are some of the ideas. We'll definitely make some audio, and we might make some TikToks as well. And of course the open textbook.
Hi everyone. My research interests are virtual reality, mainly increasing presence through embodiment, making the boundary between the virtual and physical worlds a little bit more seamless, and leveraging VR for beneficial purposes. Today, I'm going to talk about a recent research focusing on making the boundary between the virtual and physical worlds a bit more seamless. So in everyday interactions with others, we usually affect each other's space through shared physical objects. We can pass some objects to each other, and that passed objects make a difference in each other's physical space. So similar to that, in this research, we are focusing on how we can improve user experience in virtual reality with bidirectional embodied tangible interaction between a human user and a virtual character. So kind of like passing an object, we are trying to see if we can create the illusion of passing a tangible object to a virtual character and vice versa. So for this, we created shared objects that we call real virtual objects that span the virtual and physical boundary. So these objects that you see here, they are kind of like half physical, half virtual, and we are syncing the physical and virtual parts so that they move in synchrony, and we can create that illusion of objects passing through the curtain. So here is a video of the research. We project the virtual world on a projection curtain, and we alter that projection curtain so that it has holes with matching sizes with those physical objects. And then we have real and virtual parts that are synchronized to create that extended illusion of objects. So whenever the virtual character moves the object, the movement is applied to the physical part and vice versa, so that each user, human or virtual, can make a change, can affect each other's physical space. The virtual user has a virtual space, but in the human user's mind, it's their space. So each other can make an effect on the other's place. And then they have a collaborative task. They are sorting boxes and putting them in their respective bins. And we have a control version, like you see in this one. In that one, we separated physical and virtual. So each user has their own controllers, and they're not making an effect on each other's controller. So we hypothesized increased sense of presence and co-presence with this research, and that was our whole motivation. If you're not familiar with the terms, sense of presence means the feeling of being there in a virtual environment, and sense of co-presence means the feeling of being in the same place with another and dynamically interacting with another. And we performed a between subjects user study with 40 participants, and currently preparing the paper for submission to Kaiplay. A quick summary of the results: we saw increased presence and co-presence in the real virtual group who played the game with the shared extended controllers. And then also, it wasn't our hypothesis, but effective attraction towards the virtual human was increased in the real virtual group. So when they shared that object, they liked the virtual human more as compared to the group who played the game with separate controllers. And also their success rate increased. They mentioned having an increased sense of responsibility because they shared the object with the virtual human. They told they felt responsible for performing better as compared to playing the game with separate controllers. So what's next in this research is we are curious to investigate the effects in spatial augmented reality. So we tried this with fixed virtual reality, but we are curious if the effects would be similar in the spatial augmented reality or mixed reality. And then we are also curious, we started with primitive objects, a wheel and a block, but what would the effects be with objects of different forms? It can be more detailed geometry, larger or smaller objects. And also we are curious about what the threshold will be at which humans would start to not notice the real virtual extension and would get totally immersed, or the opposite, when they would notice. So for research like this, we are always looking for talented students, for game development, virtual reality development. If you're interested, reach out, and this is my email address. And if you have any questions, I would like to take them.
Time for a couple questions. Thanks, that was interesting.
Sure.
So have you tried to see if you have a non-human avatar on the other side? It's like, like a creature or a cat or something, just having an interaction with that and seeing whether, kind of the effects.
Correct, that's a great idea. We haven't yet, but I think that would be another interesting research direction for next research. That's another aspect. We started with a virtual human, mainly because in previous work, all co-presence and presence is more established with interactions with virtual human, but that's another exciting area, especially with virtual animals, which can be rehabilitative, and it's kind of like a emerging topic right now. I think that would be another interesting future research, but we haven't yet. Yes?
This is such cool research, thank you.
Sure.
I was curious, how do you measure the sense of presence? Is it self-report and some physiological?
It's self-report in this study. There are some other studies where some physiological data can be used as well, like heart rate, increased heart rate. But for this one, we relied on the presence questionnaire, which has this set of questions, and there's another questionnaire for co-presence, like around 40 questions or something, and we have the participant answer each question afterwards and take the average and rely on that self-report for this research. Do we have time for another question? Or?
Yeah.
Okay.
I just had a quick question. I was wondering, are all the environments that were displayed on the presentation, are they preset environments with the textures loaded on top of them pre-made, or are these environments being mapped in real time?
No, they are pre-made. Let me pull up the video quick. So they are pre-made, and we created this environment to be as similar as possible to the physical world. So the carpet you see was very similar, actually a photograph of the physical room. There are some other procedural games that we can generate, but in this one, the boxes are randomly generated if you are talking about it, but the environment is pre-made, preset, and we try to develop it as similar to possible as the physical environment to have that continuity illusion. But of course, in the game, the boxes are generated in real time, and also the controllers can be moved in real time. Those aren't dependent to a script. So it's interactive. You can move them in real time as you like, and it's responsive. But the environment, if we're talking about the room and other virtual textures, those are pre-made.
Got it. Thank you.
Sure. Thank you.
Hi, I'm Rochelle. I'm a professor at the iSchool. I'm also the advisor for the MLAS program. And today I would like to talk to you about some research I will hopefully be doing in the probably the longest and worst title we have here today, but it's not actually that. So the agenda, I'm going to give you a brief introduction, which I basically just did. I'm going to give you a little description of our proposed study, and then I'll talk about the opportunity for students to be involved, and then the timeline of how this would work. So the proposed research, as you probably got from the title, is to analyze DEI content in library and information science programs. So I'm sure everyone knows this, but DEI is diversity, equity, and inclusion. So there's been a lot of discussion about this and kind of experimentation and adding it to curriculum. But what our question is has there actually been substantial improvement? And what does improvement mean and what does improvement look like going forward? So the schools that are so far involved, and this isn't an exclusive list, this is just what we have so far, is Sarah Ryan at the University of North Texas, and she's kind of been the leader in this research so far. And then Teresa Miguel Stearns, who is the Law Library Director here. Shamika Dalton, who is also the director at the Law Library at the University of Tennessee. And then Renate Chancellor, who's at Syracuse University at the high school. And then me. So our primary goal is, again, to assess progress towards equitable and inclusive curriculum assessment models, and curriculum revision models. So we don't want to just take data from a snapshot from any given semester. We also want to look at what schools are doing for how they're actually assessing going forward with curriculum assessment, and then also how they are modeling revising curriculum. So we're trying to kind of see how schools are planning for the future and also how they're assessing it. So we want to look forward and not just any given semester. So this will be cross-institutional research, as you probably saw from the list. So right now we have U Arizona, Syracuse, and UNT, but we're hopefully going to get some other schools on board too. And again, the focus will be on library and information science curriculum. Oh, I want to pass something. Okay, what I also wanted to focus on was why it's going to be student-led. So you might have seen from the title that this will be student-led research. And so there is kind of an important reason for that. So there have been past challenges with getting DEI into curriculum. And one of those is a lack of student participation. And so I don't mean that students don't want to participate or that students aren't interested in this, but just that students haven't actually been given the opportunity to do this. So we would like to change that. And then also the distinction between increasing DEI material overall and then actually improving diverse students' experiences of the curriculum. So, I mean, we all know that increasing DEI material benefits everyone in the classroom, but we also want to focus on actually the diverse students in the classroom. Is their experience getting better? Is their experience improving? Because we also believe that for U.S. curriculum to reflect the experiences of insights for our diverse students, including those who would matriculate if college was perhaps more welcoming, relevant, or valuable, students really must drive the process of curriculum reform. So, that being said, there hopefully will then be a lot of opportunity for students to participate in this. So the way we're kind of thinking about this is that the first phase would be like a class that would just be focused on the data collection. So that would be one semester. And then another semester would be student-led data analysis. And within that would be kind of debating and determining research finding. And we said debate because we're a bunch of lawyers, but actually it's more kind of like having deep conversations to actually try to understand the meaning, importance, and actual practical relevance of the results that we get. And then students would then be able to create material to contribute to faculty and staff trainings, and then eventually be involved in curricular revisions. So the timeline for this. So year one would be this coming fall, and that's kind of just the planning phase. And then for the spring of 2024, so like in a year, hopefully we would have a course ready to go that students could actually take, and then that would be where we would start to collect data. And then in the fall of 24, that would be the analysis, and then 25 would be actually hopefully then taking the analysis and the results and developing training materials. And then kind of summer, fall 25, students would be able to then go to conferences and present and create posters of what they found. So Our funding is in progress. We've applied for a Spencer Foundation Educational Research Grant. The reason I wanted to share this with you all today is because this is really student-driven and student-led, so I'm hoping to get as many students interested. So if you are a student, if you have students that would be interested, please let me know. Here's my email, and you can always stop by my office too. So thank you so much.
What would you say are sort of the main library conferences or spaces where people are having these kinds of dialogues? Are there working groups that you know of?
So the ALA would probably be the biggest library conference. I also usually go to the American Association of Law Libraries. So these are a bunch of law librarians. So that would be one of the conferences. Locally, we have the AZLA, and then Elise, I think I'm saying that right, ALISE. So those are some of the groups I'm thinking of off the top of my head. But yeah. Any other questions?
I was just wondering what kind of content, do you have an example of the kind of content you're talking about? When you're talking about, the content that students are focused on finding or
Oh, what would be the actual, what they would be looking at?
Yeah.
I mean, I'm not sure that we have that nailed down yet. We're like, this is very early stages. But, so do you mean kind of with like the quantity versus quality issue that I was talking about?
Yeah, I mean, I'm just wondering what's an example of the type of content?
Yeah, I mean, I think just like even having, I guess just from the most basic of just like, does the curriculum include diverse readings or that kind of thing would be maybe a quantity issue, and then quality, I think, would probably entail actually really digging into the material and then having discussions about it. So that's kind of why there was like that whole debate section of analyzing the research.
Thanks.
Yeah. Yes.
I guess to go off the top of your question, would you just be looking at curriculum, or would you also be including maybe other experiences, like what is their workload, what are the students working on top of this, or I don't know, personal life stuff?
Yeah, that's such a great idea. I think we were initially just talking about curriculum, but I mean, I think that's really, really interesting because so much of, student experience is also going to be what is their life circumstance and what are they dealing with, what is their experience like on campus. So yeah, that's great. I will add that thought in. Any other questions? No? All right. Thank you.
My name is Cristian Román-Palacios. I'm an assistant professor of practice here at the high school, and I'm just going to be talking about models and packages for our packages that I've been working on and some other projects that are being working on with some students at the high school and other departments. Most of the time I'm teaching two courses, Info 523 and Info 531, Into Machine Learning and Data Mining. So if you're interested in any of those courses, please just reach out. I'll be happy to provide additional information or details on what we cover essentially. For now, just want to give you a brief introduction of who I am. I'm an ecologist and evolutionary biologist by training. Most of the time I'm focused on ecology and evolution, the interface, questions of the interface between those two. And I focus specifically on phylogenetic systematics, climate change, and conservation biology. But you can see that some of the projects that I'm going to present on in here are going to be out of those specific fields. First thing, a while ago, 2019, we put together our package that essentially merged or focused on improving the performance of just the phylogenetic comparative pipeline or just toolbox in R. So this was treated at table. Paper was published just on PreG, and I had a couple other co-authors from a couple other universities. Fun project that got me started to think out like what the implications of fast and open science and reproducible science were. So recently I started working on our package that essentially was focused on putting together a whole workflow for inferring phylogenies. So this is handy for many folks, essentially, because like right now you have a bunch of software that you have to use to just treat a phylogen. Phylogen is something like that. It's a tree that shows the evolutionary relationship between taxa. So these are packages focused on retrieving sequences, doing some sort of curation in terms of orthology and taxonomy, alignment, partitioning, and finally tree inference. The package is called Fruta, just a joke in Spanish to some extent. It does all of those steps, but it also focuses on increasing reproducibility and access to just the toolbox in R for doing phylogenetic analysis. For now, there is a preprint out. So a couple weeks ago, I presented at SSB in Mexico City. Probably the first venue to present on this R package. Has its own official website, and it was peer reviewed. At least they call it peer reviewed. So it's been in peer review or has gone through different rounds of peer review. I'm the only author, but contributions or more folks have contributed to this R package over time. There is also a Shiny app. So the Shiny app mostly focuses on increasing access to Fruta, their package. It's also in Spanish and English, so it's kind of cool. More folks can actually use it, even if they don't know English. It's point and click, so you don't even need to know how to code in R, for instance. And it was released to the Data Science Institute through one of their servers, essentially. So it's live, and it's a beta version, this version of the Shiny app. So this is enough about me. I'm gonna just be talking about what other folks around me are currently doing. First person is gonna be Danielle Van Botel. She's a PhD student at the Applied Math department. She's working essentially on just changing the structure of BART. BART is Bayesian additive regression trees, and she's basically taking the tree focus on BART and replacing it with a model. Just essentially, to some extent, it's going to be Bayesian additive regression networks, so neural networks instead of trees. And she's extending the framework to include other models instead of just neural networks. So far, she has implemented, the first version of the code and wrote a first draft. This is going to be her dissertation. Seems so far that it performs great in many different situations. It's mostly a generic approach, so you're going to find it either being the best one or the second best approach to data sets of different complexity. So this is a cool project. Just stay tuned. She'll probably present at the iSchool at some point. Kwan was a master's in information back in 2022 last year. He worked with me on his capstone project. We essentially put together some Bayesian linear regression models for calibrating the cloud isotope phyllothermometer. And we have this publication, this manuscript is under review right now, and he's one of the co-authors. So it was a great collaboration with Kwan. Tons of just improvements to what we had, and he was able to just gain some knowledge on Bayesian inference from this side. Wong Kian, he was also a master's in information back in 2022. He worked on his capstone, but then I hired him to finish up working on this paper. He's now back in Korea. But essentially we simulated some synthetic populations and figure out the effects of just climatic conditions versus like history traits in predicting extinction, at least in those synthetic scenarios. This paper is currently under review in PNAS. So yeah, this was a great and lovely collaboration with Wong Kian. Kyle, who I think that some of you have had the pleasure of having him in your classes, or he's currently either collaborating with you or taking your class. We work in a manuscript mostly focused on just generating a framework under unsupervised learning that enables us to compare cities across the globe using mostly demographic and environmental characteristics. And this mostly focus on urban ecology studies, just to figure out which cities are comparable and which ones are not. We have a manuscript, and we're just getting input from other collaborators on this one. Román-Palacios, she's at the Data Science Institute, and she's also a master's in data science student, current student, working on the Santa Cruz River and Equalize, trying to see if we can classify different levels of essentially just trying to get a sense of whether there are conditions in terms of E. coli population size that are pervasive at some extent in different places of different areas in the Santa Cruz River. So she's working on the machine learning side, and right now she's collecting data just on just different places across the river. So this is a cool project, and it's sort of local. Has some additional projects. I just wanted to mention some folks here. Sophie is working on machine learning and phylogenetic reconstruction. Reza is working on climatology, mostly improving some models. I've been working with Eastern and Francisco Javier on just remote expert surveys, just releasing surveys so people in different places, mostly conflict areas, can actually provide information to social scientists in a safe way. And more recently, I got a small grant to work with Mackenzie Water at the Landscape Architecture Department. And we're working with Zack, Heidorn, also at the Master Data Science program, to just put together an app for doing public science or citizen science in terms of planning. I'm also affiliated to the Center of Diverse Leadership in Science at UCLA, and we're currently working on putting together a manuscript that explores just the changes in anti-blackness or anti-racist just letters in the U.S. from the 1970s or 68 specifically to the 2000s, early 2000s. That's gonna be it. So thank you so much for just being here and listening to this summer. And I will take any questions.
So I have an interest in reproducible science. However, this often kind of clashes with practical realities. And there's like a spectrum of like how much you can do to make things reproducible. Like, do you provide like the exact system specs that you used, or like a Docker container, whatever. So I was wondering where you fall, or do you just sort of like throw your crappy academic code on GitHub, which is mostly what I do, and say like, it's out there, use it to your own risk. Try to make it good. Still, where do you fall on that spectrum?
So yeah, that's a good question. So when I started putting or working with code, like I didn't have any sense of what reproducibility was. So it's been a long way for me. I'm still learning how to just put stuff out that is useful for people. So yeah, you're gonna see papers that don't have code that are in my CV, and other papers that are, the most recent ones have just GitHub and just like examples and essentially just license and information on how to actually use it. So it depends on which state you're asking out. Right now, I tend to just like, for instance, I create tools. Most of my papers actually just I put things together in R packages, for instance, because that's what my field is using. So I put it together and then I create just websites essentially, and also vignettes on how to actually use it. But I tend to right now put stuff together in packages, because I think that is a good way, at least for folks to just follow on what I'm doing. That's the best I can do for now, especially because the field is moving very slowly in terms of that. And people wouldn't have access if I just use another language, or if I just put a stuff on or Docker, like, yeah, people wouldn't use it. So that's move forward essentially for me and for the field. Yeah. Is that enough, of course?
Yeah.
Yeah.
Thanks.
Yeah. Any other questions?
You are working on so much, that's amazing. So good job. I was wondering with the urban ecology project, do you have any early findings from that? Are you finding like unexpected cities that are comparable to each other?
Yeah. So what we're doing as supervised clustering, we have like just essentially six big groups of cities, and those cities don't follow like a continental-based pattern. So you don't expect cities in the continent to be part of the same group, but there is some dependency in terms of distance, right? That's basically what we have found, and we're just putting together like an app that allows people to say, yeah, I'm gonna sample populations in this city, right? Which is the closest city in this cluster that I should be sampling to make things comparable, or the most divergent one relative to the city that I have access to. And that's to make essentially some analysis in terms of, for instance, parallel evolution, whether cities in different areas are, just essentially getting a sense how different they are and how similar those populations or species are in terms of their evolutionary characteristics. So just quantifying the distance between cities can actually help you to get a sense of whether it's parallel or not. So we're gonna put that framework out hopefully soon. I'm making some adjustments in terms of the unsupervised learning part that is relatively new, because we don't have any synthetic data to just know that those groups are actually real.
Super interesting.
Thank you.
I'm Dr. Andrea Thomer. My talk's on building infrastructure for past global change research. So this is about a project that's just getting kicked off right now, but I am super excited about. I want to start with just a quick introduction because I'm brand new here and some of you don't know me yet. I'm Dr. Thomer. I use she, her pronouns. Short version of my bio is that I come to information science by way of natural history museums. So long story, but I wound up working at the Library of Tar Pits in Los Angeles through college and after college. And from there, I got really interested not just in the science that we were doing there, studying Ice Age animals and things like that, but also got interested in why our infrastructure was so bad and got very interested in thinking about how we could make it better and how we could use that data to inform studies more broadly. If you are not familiar with natural history museums, the way that I want to put them forward for you guys right now is that think of natural history museums as giant distributed databases. And they have large collections of stuff, and each of these individual fossils or specimens or artifacts represent an occurrence of an animal or of some sort of group at different places of the world. There are literally billions of these specimens all over the planet. We do not know how many exactly because most natural history museums do not have complete catalogs, because most natural history museums do not have enough staff. But when you start bringing that together, you can make things like this image in the lower right-hand corner, giant maps of the distributions of different organisms over time. You'll see in this heat map that the hottest area is North America and Europe, and that's because these collections are incredibly biased, and that's part of the reason it is important to try to bring them together so we can see where those biases are and start thinking about how do we support undersampled regions and how do we get that data back to the places that it actually represents in a lot of cases. So the project that I want to talk about today, we just got this funded, and this is also my first time talking about it, so bear with me if I stumble a little bit. It has a very large and painful name. It's the Pharaoh's Disciplinary Improvements for Past Global Change Research, Connecting Data Systems and Practitioners Research Coordination Network. So this is an NSF-funded RCN, Research Coordination Network, where we're bringing together lots of people with the goal of building technical and social capacity by supporting, we're bringing people together to make infrastructure for biodiversity informatics, specifically focusing on recent past global change, and I'll unpack that a little bit. So we want to build technical and social capacity by supporting technical implementations of ethical open science principles and developing communities of practice focused on care and fair principles. Some of you have probably heard those, but fair is basically making data open, shareable, accessible. And that's where the Pharaohs comes from in this title, and that was something that NSF came up. The care principles are not as well known, but are starting to, they're newer also. Care principles are grounded in bringing collective benefit, authority to control, responsibility, and ethical use of data, particularly focusing on indigenous communities from which that data is being taken from. This is a graphic. I'm not going to go through this graphic, but because we're focusing on recent past global change, we're looking at recent paleontology data, but also archaeological data, and that's why it's particularly important to bring these care principles into play, because they are these are specimens and data that are taken from currently from indigenous communities, and it's really important to make sure that they actually get some control over that data, not all of the control of what happens to that data now that we're trying to share it. This is a big multi-institutional project. Jessica Bloys at UC Merced is the lead of it. I'm on what they keep calling the IT team, and I need to get them to say informatics instead because we're not fixing routers. Me and Simon Goring are leading the informatics initiatives of this, so basically trying to make data interoperable. Maybe I should put this slide first, but the way that I try to explain this grant is that we're trying to make quaternary data science a thing. And that's how we bring together this recent paleontology and archaeological information. So the quaternary period is a geologic time period. It's the current and most recent one, about 2.5 million years ago to present. And it includes all of these very diverse kinds of data, stuff about animals and people, because of course people are types of animals, and trying to reunify this data in these disciplines that have been traditionally siloed.
And like I said, it does have these unique challenges because of both the diversity of the kinds of data and because there are some serious ethical considerations that you have to think about before just putting this onto the web. And because museums do have these colonial legacies, and part of what we want to try to do in this project is start unpacking that and thinking how we can have better practices in museums and starting to try to remedy that a little bit. So this is a map of basically that diverse network of data resources. I won't go into all of it, but what all of these different boxes represent are the different disciplines. So paleoecology, modern ecology, archaeology, and paleoclimatology, but also a ton of different databases that are harvesting and making available data from museums and repositories all over the place. One that I'm going to call out right here is iSamples. This might be a project that folks here have heard about because Hong Kui was the PI who adopted it from Ramona Walls. Now she's passed it on to me. So we're going to try to be working with the iSamples network for some of this work. Some of the main challenges that we're trying to address here, the first one, data interoperability, that's what I'll be focusing a lot of my work on. So there are big differences among data resources in their degree of adoption and knowledge of common data standards. Basically, we want to look at what are the technical and social roadblocks to bringing data together in something that can actually be used for a comprehensive study. The second challenge is data resource growth and complexity. Lots of researchers just don't know how and where to contribute their data, and a lot of these projects are growing in large ways that we don't totally know about, so we just basically need to map that landscape and better understand how that is and help people get access and know what to do once they've collected data and they want to share it. And finally, there's huge inequities, both in who gets to do science and who gets access to the science that's already been done. And that's something that we're trying to address through application of care principles. So, the work at UA, like I said, I'm the head of the informatics team along with Simon Goring. We've got 3 main activities that we're going to be doing here. I'm hiring a postdoc, but I also would love to hire some undergrads and grad students if you guys are interested in small parts of these projects. We're doing things like mapping the quaternary data science landscape, which mostly means trying to get a better sense of what are all the data resources out there, understanding data practices and needs, so doing some basically social science research to know how people work with data and figure out how best to support them, and then developing interoperability standards to bring all of those data resources together. So if anybody is interested, please talk to me. I also have other projects that are kind of related to that I'm not going to try to talk about today. So, thanks.
This is so cool. Congratulations on the grant. Thank you. What are the research sites that you're thinking about for some of the museums?
So our current partner, so it's a research coordination network, which is different than a traditional grant. We're kind of doing research, but we're mostly trying to build community. So the existing sites are all of the PI's various homes, plus some of the museums that we're affiliated with. So places like the Florida Museum, and let's see, Open Context and the TDAR databases. So it's less physical sites and more these infrastructures that have been getting built up for a while. So. Questions?
All right. So I do lots of stuff, sort of all the intersection of natural language processing and machine learning. But I'm only going to talk about one little thing because that's about the amount of time that we have. So I'm going to be talking about matching textual locations to ontology concepts. And when I say this is my research, I mean basically my student did all the research and I just get the glory. So really this is a use work. Zayy's my most senior PhD student, should be graduating this semester. So this is sort of his newest, coolest stuff. All right, so basic task here is sometimes called toponymy resolution, sometimes called geocoding. The idea is you have a bunch of text, and places are mentioned in that text. And you would like to figure out actually which place was mentioned, right? So if you see San Jose, it turns out there's like a lot of San Jose's, like thousands of them across the world. And if you just sort of arbitrarily pick one from the ontology, it's probably not the one that you wanted. And there are lots of things that can help you decide which is the right one. In this example sentence I've given you, it's pretty explicit. It actually says it's the one in Northern California. In most cases, you don't have something quite so explicit, so you might be looking for other context cues. If there aren't exactly context cues, a good bet would be like the most populous one, right? If I say Paris, but I don't give you any other context, probably you mean the one in France. Although I guess you could mean the one in Texas, depending on where you're standing. So there's a lot of complexity in what seems like it ought to be a really simple problem. What I've shown you here is the ontology here that we've been working with, although there's a few different options here, is geonames. And geonames basically has, for each of these possible locations in the world, it has a bunch of metadata about it, like, you know, the actual geographic coordinates, the population. It'll often have, if there are alternate names, other language alternate names, but sometimes there's more than one name in English for the same place. That happens as well. So all of those things are sort of metadata in there, but somehow you have to take the text that's not explicit about this and match it up to the ontology of this. So that's the basic setup of the problem. How people approach this problem in the past, well, for decades, what they did is basically sort of complicated string matching and a bunch of heuristics, right? So maybe you might try to find other things nearby and do some sort of calculations over their, you know, how far away they are from each other. Population has always been a very strong cue, so that's like a baseline for most of these systems. In the last few years, people get really excited about deep neural networks, because that's basically what took over my entire field. And they said, forget about the database. What we should do instead is we'll just try to map each text into like a little, you know, a tile of the Earth's surface. So we'll just sort of directly predict the tile of the Earth's surface. And so there are a series of models that came out like that. It turns out that that's not as cool of an idea as it sounds like. So what Zoe did was come up with another way of approaching this. So one of the disadvantages of going directly to tiles is you no longer have all that cool metadata, right? So it really might be useful to know what the administrative district something is in. If you just give me a tile, I don't actually know what administrative districts it in. I don't know, you know, all of these other things. I don't know the actual, you know, other categories of this information. So losing that metadata is unfortunate. And we'll see in a minute that actually matters. So this is the basic approach. There's sort of two pieces to it. First, you have a candidate generator, which says, okay, I've got a giant ontology that's got a whole bunch of different names. Which of those names are a plausible choice here, right? So if it's San Jose, you probably want all the ones that are literally San Jose, but you also might want ones that are, you know, slight typos to that, because it's very common to have slight typos in text, or slight variations. So for that purposes, we use a standard information retrieval system called Lucene, with a little bit of, you know, care in how we index things. The second half is a deep neural network, because that's what all the cool kids are doing. It's a transformer, pre-trained transformer, and the basic idea is what you're going to feed into it is the name, the phrase that you're trying to resolve, and then the canonical name of the entry that you're asking. Are these the right ones? Is this a good match? And then all the other information that all of these other prior things used. So, you know, some encoding of the population, some encoding of like the feature class. So is this a city or is this a state? Some encoding of the context, which is also just gotten by running one of these big transformers over. You can concatenate it all together and let the machine learning model figure it out. And at the end it says, oh, I like this candidate best out of the list that you gave to me. So that's a very good start. That actually already beats all the previous research. He's got sort of an extra cool step on that. So the second intuition is it's much easier to resolve countries than it is to resolve cities, right? There are fewer of them. There aren't that many places named China or Uzbekistan, right? So there's not too many of those. So the models are usually pretty good at them, and they usually don't need a lot of context to do that, right? And the lower you get down the hierarchy, the harder it gets, right? There are lots of places called Paris. There are lots of places called San Jose. But there aren't that many places called Arizona, right? So what do? Well, you do the easy ones first. And then you use the easy ones as context to help you resolve the other ones, which hopefully is sort of what you, as a human, already did back here. Well, I know what Northern California is. I know that. There's only one Northern California they could be referring to, so I know which San Jose that is. So this is sort of the algorithmic equivalent of that,
In this example here, you first resolve Canada and Alberta, and it turns out the model is pretty confident and almost always right for these kinds of things. And then you use the canonical forms of those, Canada, and 01 is the code for Alberta in geonames, and you just concatenate those in as sort of extra context. And it turns out, I mean, unsurprisingly, it's very helpful. So a brief summary of like 300 numbers that I just picked a few, because they all pretty much look the same. The first two models are existing models. The first model is a really old model, but it's honestly really still a very strong model. When you fix the cheating bug in the neural network, it was an inadvertent cheating bug. They were basically using gold information from the ontology. Anyway, so those are two prior work, and you can see that the third row is basically corresponding to the first diagram that I showed you, and the fourth row is the second diagram. And in both cases, we widely outperform all of the prior work. So kind of simple ideas here that marry some simple information retrieval techniques with deep neural networks to get state-of-the-art performance on resolving geolocations. All right, that's what I have to say. Thank you.
Quick question, a couple quick ones. So what are LGL, GW, and TRN?
Those are different data sets. So there's a bunch of different data sets for evaluating, they're basically humans have hand labeled, this is the correct ontology entry for this Paris.
Is TRN like the most recent or the easiest, or, like?
They're all basically newsy stuff, so they're all a little bit constrained that way. TRN turns out to be the easiest one. It just happens to be LGL is local news, and so those can be harder. They tend to be less, sort of the big name things and more local stuff. So, but these are also all small data sets. There's certainly need for like more, better, diverse data sets to evaluate.
The other thing I was wondering about is, so how much context do you take into account? Like, just one sentence, or
so the answer is, in this one, it was a hyperparameter, and we looked over a few different sentences. I think the best model was with one sentence before and after, although it didn't make a huge difference. When you move to this model, though, it turns out that you actually don't need any other context.
Oh, that's nice.
You can just use these. You throw away the entire, so the advantage here is these are document level context rather than, a couple sentences before or after, because these neural networks can't take the entire document, it's too large. But you don't need the whole document if you have all of these sort of, countries and states that you can use as context.
Cool.
So, yeah, great question. All right, thank you.
I'm Dr. Zack Lischer-Katz, assistant professor here at the iSchool, and today I'll be talking about curating and preserving visual information. First of all, what do I mean by visual information? So we can think of objective models of vision and perception that are trying to describe our physical and cognitive abilities, neurobiology, things like that. That's not really what I'm talking about here. I'm thinking about visual information in the sense of going from our perceptions, our engagement with the world, to knowledge, to building knowledge. So that's the scope of these things that I'm going to be talking about, such as meteorologists, as you can see in this photo here, looking at radar and their simulations and things like that, or entomologists working with their bug collections and things like their specimens of exciting butterflies. Some things that are in natural history museums as well. Or even individuals organizing family photos or building visual knowledge in some way. And then the other question, what is what is digital curation, right? And so we have a lot of, it's brought up a couple of times today, but I'm looking at the Digital Curation Center model here, the big bullseye, which I'm not going to ask you to read. And they define digital curation as maintaining and adding value to a trusted body of digital information for current and future use. And so this term embraces digital preservation, as well as data curation and management of assets through their life cycle, from creation to archiving to reuse. And in this cycle here, I'll be talking about kind of the creation dimension and kind of thinking about how we can bring curation thinking into the curation stage, even the planning stage, before we even do research or create visual information, as well as the access and use and reuse phase, and then transformation, which are areas that are not often studied, at least in my view, digital curation field. So I'm drawing on my earlier research back in the day for my dissertation, looking at the technical work of digitizing analog videotapes. And I focus on highly skilled labor around that. So these are media archivists working with videotapes in museum, library, archive collections. Sometimes it's video art. So it's important to copy these in a way that maintains the intellectual or aesthetic integrity of them. So I looked at their lab work, looked at the discourses, and how are they constructing knowledge in their work. And some of the things that came out of this were it became clear that it was really important to study this moment of transformation, moving from the analog world to the digital showed how much that's a translation between different signifying affordances. Another thing that came out was the importance of standards and how that shaped the practices of the practitioners that I was looking at. And so there's also implications for how we design digital curation tools, looking specifically at how people actually do the work of curating information through its life cycle helps us build better tools, better standards, and better practices. And so I'm going to talk through a couple quick projects here that are kind of new and exciting and developing. This grant I'm writing with colleagues, or a colleague at Harvard University Library, from the little town called Cambridge. We're building out this project we conducted with Virginia Tech and University of Oklahoma, and what was the other one? Drawing blank on the third one. But we put out some reports based on that. I also had a Council on Library Information Resources grant for this 3D VR symposium. So we looked at the ways that libraries and curators and also content creators were trying to deal with this question of 3D data. So archaeologists are creating 3D data from their archaeological sites. We also see using 3D data in virtual reality. So we kind of had this idea of looking at those holistically. So looking at the creation of 3D data, but then also the uses that it might be put to in augmented reality or virtual reality or these other emerging media formats. So we're revising the grant, we're resubmitting it. We got through the first round, which is great. So we've been asked to submit the full grant to the Institute for Museum and Library Services this March. So we have like 6 weeks to put it together. So if anyone wants to look at our application, I'll be very happy to share it. So the goal of the project is to develop some 3D curation guidelines and we're going to use qualitative methods, interviews, participant observation, document analysis. We're recruiting 6 research labs on campus. We have plant scientists, a biologist, and also some humanists. So we have some colleagues at University of Oklahoma who do work with medieval manuscripts, 3D scanning those. And so you think these manuscripts from the, I think, 10th century are actually they have a lot of contour and texture to them. So 3D scanning actually brings out a lot of new information. We're looking at different scales and tools. So photogrammetry, LiDAR, structured light. And then we're hoping that we'll develop new techniques for curating and reusing 3D data across disciplines and also using 3D data, create a pipeline to use 3D data in VR projects and things like that. Libraries are increasingly using 3D data. And the Smithsonian, for instance, is scanning a lot of their materials to make them more accessible. This was an issue during COVID as well, so you can't go to your archive, your library, or your museum to see things. And texts are a little easier to digitize and put out into the world, but 3D scanning, you can scan objects and artifacts and make them available to researchers and the public. So we see it as really a sort of pressing issue to create the tools for curating 3D data. And then this is another project that I'm working on with Dr. Brian Carter here at the U of A. He's at the Center for Digital Humanities. He's doing volumetric video capture, which is basically 3D video, but not in the 3D sense of Avatar or films like that, but actually having cameras all around the subject, and you're basically creating a 3D model of your subject, usually a person. I don't know if anyone saw the U of A's president, his holiday greeting. He created a hologram of himself, and so you could drop him into the middle of your room, and he'll talk to you. And you can look, you can walk around, and so you can see here, creating, taking all these pictures, knitting them together, creating a 3D model, and then putting that 3D model into whatever space, your VR project or your AR app. And it basically is a series of film and video made of frames, right? So instead of frames, you basically have individual 3D models for each frame of video. So it creates some interesting issues around film issues, sound issues, 3D model curation issues, metadata issues. And so the project I'm working on with Brian, as well as a colleague at Williams College, Dr. Rashida Braggs, in the Africana Studies Department, will allow us to start to develop some standards and best practices for volumetric video capture, curation for the humanities. So they're working on this project. The full name of it is Preserving BIPOC Expatriates' Memories During Wartime and Beyond, Building a Volumetric Archiving Platform for Immersive Storytelling and Historical Preservation. So they're interviewing folks from African-American veterans of World War II, such as Tuskegee Airmen, so the fighter pilots during that period, and capturing their stories in volumetric video. And the idea, the reason I was brought into the project was we could start to think about preservation and curation questions from the beginning before we start collecting any data and start to develop a pipeline for that. And so we got a $50,000 grant from NEH, from the Digital Humanities Advancement Grant Program, and we're going to go to Berlin this summer, actually Potsdam, to go to the studio called VolueCap, and they basically are doing all the Hollywood level volumetric capture. They did The Matrix, the newest one, and so we're going to hang out with them for a week and learn about their high-level process, map that out, and then and then also compare that to our sort of medium quality process we can do here on campus, and then think about like a lower quality kind of app-based volumetric capture. So we're thinking about different scales and how those scales, understanding them, can develop kind of approaches that will be more reproducible for scholars in different fields. So it's geared towards the humanities scholars who are often under-resourced, right? So we want to think about different, depending on the grant money you have, what level of quality you can do for that. So that's exciting. So that grant will finish up, I think, in January of next year, and we'll be applying for a bigger NEH grant to support that and see what happens. So yeah, so I may be looking for students to collaborate with, and yeah, thank you very much. I look forward to your questions. Questions, comments? There's a lot in there. Yeah, Ronnie.
So how fast are these technologies moving? Because my sense is that they're moving really fast, and also because of also all this additional stuff with machine learning, where you just like extrapolate some of the information if you collect the data from before and say, yeah.
So the question is, how fast is it moving, and is it bringing AI and machine learning into it? Yeah. So we're dealing with a lot of folks need to leave, please. We're over time. So yeah, they're upgrading the facilities, but the data rates are huge. So we're just for our medium scale data rate here, it's like 200 gigabytes a minute, right? That's the raw data coming off all the cameras and things like that. Now, VolueCap in Germany, they're dealing with probably like 10 times that amount. So yeah, I think they're starting to use like machine learning and AI and things like that to kind of process that in some way. So the raw data is coming out, and then it takes like a day or two to start to process it, to have like a 5-minute clip of that. But they said they're using these higher end machine learning and things like that to speed up that process. A lot of it is like compressing those 3D models, right? Sort of determining what you can sort of calculate out of that, right? Decimating those 3D models and things like that. So yes, it's changing very rapidly. And you saw President Robbins hologram, like the resolution wasn't that great on that, at least on my smartphone. So I think a lot of other things have to kind of increase the bandwidth and things like that before we're at like, really crystal clear holograms everywhere. Other questions? Yeah, Sarah.
You mentioned a really interesting, sort of maybe unexpected thing that where by scanning you might actually find more information emerges, such as like the contour of a manuscript, etc. Are there other aspects, or is that part of your work at all? Seeing what other, if there's any other dimensions that emerge through the scanning that might add something to curation, the field of curation.
Yeah, absolutely. That's why I like to look at the work and interview content creators in that sense, right? Understand what is there, because there's been some work on 3D data curation, working from case studies, but also kind of librarians and archivists kind of trying to create standards and best practices. And I think sometimes those sort of things get lost, right? Because you're not necessarily looking at what someone's specifically doing. I don't have a good example right now, but the case of the medieval manuscripts shows, yeah, there may be other uses that we don't know about, and so being open to additional uses of our 3D content in the future. Also, it's getting cheaper, but it's still expensive and time-consuming to create 3D material, and so the more we can keep it and make it as usable as possible. There's lots of questions. You keep all the raw scan data, you keep these intermediate stages, you keep the final products, what formats. I mean, it's still a lot of questions, and we don't know. We might want to keep all that raw data because we can process it better in the future and have better things. Weather simulations were kind of like that, where they can collect all this data, create simulations, and if you ran that data from the past, you might actually come up with better models. It's a little late now, but with for climate models, it might be useful, climate change models. So. Well, thanks everyone. Thanks for coming.